For as long as humans have looked up at the stars, we have wondered if we are alone in the universe. But what if the more unsettling question is whether we have ever truly been alone here on Earth? Our species, Homo sapiens, has existed for roughly 300,000 years, a blink in the incomprehensibly long history of our planet. The Earth itself is over 4.5 billion years old, and for most of that time, life has thrived, evolved, and vanished in cycles that stretch beyond the limits of our imagination. Entire species have risen to dominance, reshaped the ecosystems around them, and then disappeared without a trace. Civilizations, if any existed before us, would not be immortal in the face of time. They too would have been swept away by the slow but relentless forces of geology, climate, and extinction. The ground beneath our feet is not a fixed archive of the past. It is a restless, churning ocean of stone that swallows its own history. Even the towering skyscrapers and sprawling cities we have built will not last forever. In a million years, the rusting skeletons of our bridges will be dust. Our monuments will be gone, and the faintest chemical whispers may be all that remains of our time here. It is easy to think of ourselves as the pinnacle of Earth's story, as if human civilization were the inevitable climax of an epic that began in the primordial seas. But perhaps we are not the first to stand at this summit. Perhaps there have been others, species that were once as dominant as we are now, with cultures, technologies, and ambitions that rivaled our own. They might have built vast cities, crossed oceans, or even reached beyond the sky. They could have looked upon the world and believed as we do that they were permanent fixtures in its unfolding story, yet time has no loyalty to permanence. Even the greatest works of intelligence can be buried under miles of rock or dissolved in the acid bath of deep time. The unsettling truth is that we have barely begun to scratch the surface of Earth's past. Our recorded history extends back only a few thousand years, and even our archaeological record struggles to reach more than a few 100,000. Beyond that, the mists of time grow thick and impenetrable, and the layers of Earth's memory become compressed, fragmented, and erased. What might have existed 50 million years ago, 100 million, or even further into eras when the continents themselves were arranged in alien configurations, when the climate was strange and unfamiliar, and when the creatures walking the earth bore little resemblance to anything we know today. We think of the dinosaurs as the ruling species of their age, yet we picture them as nothing more than giant reptiles driven by instinct, never asking whether intelligence might have taken a different form. A form that would not leave fossils shaped like us, but that might still have mastered tools, fire, and the art of altering its environment. In the vastness of this timeline, the idea of multiple civilizations is not only possible, but strangely plausible. If even one intelligent species had risen to prominence millions of years before us, the odds of finding clear evidence today would be vanishingly small. Erosion, volcanic activity, tectonic shifts, and glacial cycles are not gentle with history. They grind it to dust and scatter it into the deep oceans or recycle it back into the mantle. What little might remain could be buried so far beneath our feet that we would never stumble upon it without deliberate, targeted searching. The fragments we might find, odd chemical residues, unusual isotopic signatures, inexplicable mineral formations, would be cryptic, leaving us uncertain whether they were the result of biology, geology, or something far stranger. And if such civilizations had existed, their legacies might not be measured in ruins or artifacts, but in the subtle fingerprints they left on the planet itself. A spike of carbon dioxide in the atmosphere, traces of synthetic molecules that nature cannot produce, unusual patterns in the fossil record. To us, these signs might seem like natural anomalies, just another strange chapter in Earth's environmental history. Yet for those willing to entertain the possibility, these could be the whispers of a deep past that is richer and more complex than we have ever dared to imagine. Perhaps we are not the beginning of the story, but merely the latest verse in a song that has been sung before in different voices in ages long forgotten. And if that is true, then the real question is not whether they were here, but whether we will one day join them in silence. The idea that there might have been advanced civilizations on Earth long before humans is not just a work of science fiction. It has been considered seriously by scientists. This line of thought is known as the Silurian Hypothesis, a term coined by astrophysicist Adam Frank and NASA climate scientist Gavin Schmidt. The name itself is a playful nod to a 1970s episode of Doctor Who, in which intelligent reptilian beings called the Silurians once ruled the Earth, only to vanish into myth and memory. But behind the science fiction reference lies a deeply serious scientific question. How would we even know if there had been an industrial civilization on Earth millions of years before us? The problem is not simply about looking back. It's about the overwhelming difficulty of preserving and detecting traces of something that might have existed in the deep past. The Silurian Hypothesis begins with an observation that is both obvious and astonishing. Modern humans have only been building complex civilizations for a few thousand years, yet the Earth is billions of years old. That means that the window in which we could leave a recognizable mark on the planet is vanishingly small compared to the entire span of geological time. If another species had built an industrial civilization tens of millions of years ago, it could have come and gone in a fraction of that vast timeline. And after the passing of millions of years, the forces of the Earth, erosion, plate tectonics, glaciation, and volcanic activity, would have erased nearly all of the obvious evidence. No crumbling skyscrapers, no rusting cars, no computer chips buried in the sand. Everything we associate with civilization would be ground down into dust or melted back into the crust. The challenge, then, is how to detect something that has been erased almost completely. Frank and Schmidt point out that from a geological perspective, the only traces that might endure are subtle ones. Chemical fingerprints left behind in the soil, in sediments, and in the composition of the atmosphere. Modern human industry is already leaving such fingerprints. The burning of fossil fuels is altering the ratio of carbon isotopes in the air. Plastics and synthetic chemicals are accumulating in layers of sediment. Heavy metals from manufacturing are entering rivers and oceans. These markers are distinct from anything produced by natural processes, and in theory, they could persist for millions of years. In certain parts of the geological record, if we were to vanish tomorrow, a distant future geologist, human or otherwise, might notice these anomalies and wonder what kind of civilization could have caused them. But even this is far from simple. The deeper in time we look, the more the record becomes distorted. Sediments are compressed, altered, and chemically transformed. Vast sections of crust are subducted back into the Earth's mantle and recycled, erasing everything they once contained. Ocean floors, for instance, are geologically young, constantly renewed by volcanic activity at mid-ocean ridges and consumed by subduction zones. That means anything lying on the seabed today would be gone in just a few 100 million years, a blink in geological terms. The only areas where ancient sediments might survive long enough to preserve traces of a vanished civilization are rare, stable regions of continental crust that have remained relatively undisturbed for immense spans of time. Even there, the surviving evidence would be sparse and ambiguous, forcing scientists to interpret the faintest of clues. This leads to one of the most intriguing aspects of the Silurian Hypothesis. If ancient civilizations existed, their most enduring legacies might not be physical structures but planetary scale changes. Industrial activity, for example, could leave behind an event layer in the rock record, an abrupt shift in chemical composition, a spike in carbon levels, or unusual deposits of materials that nature alone could not produce. Some ancient anomalies in the geological record already exist, and while they have conventional explanations, it is unsettling to realize that without context, the traces of our own civilization might one day look equally mysterious. A sharp warming event, a sudden loss of biodiversity, a peculiar chemical residue. Could these be the echoes of an ancient intelligence, long gone but still faintly touching the world through deep time? The hypothesis forces us to rethink our relationship with the past. Archaeology is built on the assumption that civilizations leave behind abundant physical evidence. Ruins, tools, art, written records, but this is only true in the short term. Stretch the timeline far enough, and all of it disappears. What we are left with are ghostly impressions. Not the photographs, but the smudges left on the negatives, not the buildings, but the shadows they cast in the chemistry of the Earth. The Silurian Hypothesis invites us to look for those shadows in the most ancient rocks and sediments, to ask whether the planet's past holds secrets stranger than anything we have imagined. It suggests that our own industrial age, despite its massive impact, might be just another brief flare in an endless sequence of rises and falls, each leaving behind only the faintest of geological whispers. And if such whispers exist from a time long before humans, then they may already be around us, hidden in plain sight, waiting for someone to notice. When we talk about the history of the Earth, it is almost impossible for the human mind to fully comprehend the scale of time involved. Our sense of history is shaped by what we can personally experience. Memories that stretch back decades, stories passed down over a few generations, and written records that, at most, reach several thousand years into the past. Yet in geological terms, even the whole of recorded human history is a microscopic blip, almost too small to measure. The Earth formed over 4.5 billion years ago. For most of that time, there were no humans, no civilizations, and not even the species that would eventually evolve into us. Life itself took hundreds of millions of years just to emerge, beginning as simple single-celled organisms in ancient seas. From there, it evolved into increasingly complex forms through processes so gradual that entire worlds could have risen and fallen in the time it took for one major evolutionary leap to occur. This vast timeline is divided by scientists into a series of eons, eras, periods, and epochs. A kind of calendar on a scale so immense that a single day might represent millions of years. During these spans of time, continents drifted across the planet, oceans opened and closed, mountains rose and wore away, and climates shifted from frozen wastelands to steaming jungles and back again. Entire ecosystems flourished and then vanished, often in response to catastrophic events like asteroid impacts, massive volcanic eruptions, or sudden climate collapses. If intelligent life had ever developed in one of these lost ages, the geological processes that reshaped the planet would make finding evidence of it extraordinarily difficult. The very land they might have lived on could now lie deep beneath the ocean, crushed under miles of rock, or scattered into particles indistinguishable from the dust of the Earth. When we consider this scale of time, it becomes clear just how fragile the evidence of any civilization truly is. Human beings have existed for about 0.006% of Earth's history. Our oldest known civilizations, places like Mesopotamia, ancient Egypt, and the Indus Valley, arose only within the last 6,000 years. Yet even within that small slice of time, vast amounts of history have been lost. Entire cultures have disappeared, leaving behind only fragments of pottery, faint traces of buildings, or enigmatic carvings whose meanings we can no longer decipher. And this is from a past that is still relatively close to us. Imagine multiplying that gap not by thousands but by millions or even tens of millions of years. And it becomes clear how utterly erased an earlier civilization could become. Consider the dinosaurs who dominated the planet for over 160 million years, an almost unimaginable length of time compared to our own existence. They left behind a fossil record only because of extraordinary preservation conditions. and even then it is fragmentary and incomplete. Soft-bodied creatures, intricate behaviors, and complex ecological interactions are mostly lost forever, surviving only in rare and precious traces. If a technologically advanced species had existed alongside or even before the dinosaurs, the odds of finding recognizable artifacts from their time are staggeringly low. Without constant maintenance, cities crumble quickly. Within a few centuries, nature reclaims them entirely. Within a few thousand years, most structures vanish into the earth. After millions of years, even the most monumental achievements would be reduced to scattered atoms, folded into stone or washed away by ancient seas. This understanding forces us to think differently about our place in time. We tend to see ourselves as the inevitable outcome of evolution, the final chapter in a long story. But in the deep past, countless other final chapters may have been written, each belonging to a species that believed itself to be unique and permanent. They may have had their own histories, philosophies, sciences, and technologies. Yet, from the vantage point of today, they are as invisible to us as we would be to an observer living 100 million years in the future, long after humanity has gone extinct. Even if some trace of us survived, perhaps a layer in the rocks showing unusual chemical signatures, it would be a puzzle for whoever came after us, something to be guessed at rather than understood in full. The Earth is a restless, living planet, and its surface is constantly changing. This is part of what makes life possible, but it also means the past is in constant danger of being erased. Volcanoes pour out lava that buries everything beneath it. Rivers carve valleys that wash ancient soil into the sea. Glaciers grind the land down to bare rock. Earthquakes and landslides rearrange the surface in moments, while slower but equally powerful processes, like plate tectonics, carry entire continents thousands of miles from where they once stood. In such a world, permanence is an illusion. No matter how vast, intricate, or powerful a civilization might be, it is ultimately at the mercy of forces far greater than itself. When we see the fossilized remains of trilobites, ammonites, or ancient forests turned to stone, we are looking at some of the rarest survivors of deep time. Fragments that escape the near-total destruction of the geological cycle. For every one of these preserved traces, countless others have been lost without a chance of recovery. This makes the Earth's timeline not just long, but profoundly incomplete, a patchwork of what happened rather than a complete record. If there were once other civilizations on this planet, perhaps hundreds of millions of years ago, they might now be nothing more than the faintest of geochemical shadows, indistinguishable to us unless we know exactly what to search for. And even then, we might overlook them, mistaking the fingerprints of intelligence for nothing more than another strange quirk of nature. If an advanced civilization had flourished on Earth millions of years before us, its physical remains would face an implacable enemy: time itself. The passage of time on geological scales is not gentle. It is destructive, erasing almost everything from the surface of the planet with a relentless patience. Erosion scours away the traces of ancient structures, breaking stone into sand and carrying it away grain by grain. Winds grind down even the tallest monuments until they are nothing more than scattered dust. Rain seeps into every crack, freezing and thawing in cycles that split rock apart. Over centuries, these forces can reduce cities to ruins. Over millions of years, they can obliterate every trace that such cities ever existed. But erosion is only the beginning. Earth's crust is constantly in motion, its massive tectonic plates shifting and grinding against each other. Entire landscapes are swallowed into the depths when one plate slides beneath another in a process called subduction. In these regions, the crust carrying whatever was built upon it is dragged down into the molten mantle, where it melts and is lost forever. Even the most enduring materials, metals, stone, glass, are not immune to this fate. The ocean floor, for instance, is geologically young, rarely older than 200 million years because it is continually recycled back into the planet. Anything that may have existed on a seabed in the distant past is long gone, replaced by fresh rock created by undersea volcanoes. Volcanic activity is another eraser of history. Eruptions can bury vast areas under molten rock and ash, sealing away entire landscapes in an instant. While this can sometimes preserve objects beneath it, like the ruins of Pompeii, it more often destroys them completely, melting or incinerating whatever lies in its path. Even preservation is not guaranteed forever. Buried beneath miles of new rock, the original structures would eventually be crushed, heated, and altered beyond recognition by geological pressures. And if they did somehow survive in a recognizable form, their location could be so deep and inaccessible that no future species would ever find them. Climate change over deep time adds yet another layer of destruction. Ice ages advance and retreat, covering vast regions in glaciers that grind the land beneath them into rubble. These colossal rivers of ice are nature's bulldozers, reshaping the landscape entirely and leaving nothing of the original surface intact. Warm periods bring rising seas that swallow coastlines, submerging entire regions beneath layers of sediment, where the ocean's slow but constant activity can break down and scatter any remains. Over millions of years, coastlines are redrawn countless times, and any once inhabited land could vanish beneath the waves, its history sealed away beneath layers of sand and silt. Even the artifacts we imagine as indestructible, skyscrapers of steel and concrete, massive statues, advanced machinery, are ephemeral when measured against geological time. Without maintenance, steel rusts and disintegrates in a matter of centuries. Concrete crumbles within thousands of years. Glass fractures, then weathers into grains. Plastics may persist longer, but even they are vulnerable to heat, light, and chemical breakdown. After a few million years, nearly all would be gone, transformed into simpler compounds indistinguishable from the natural environment. The world's most enduring signs of industrial activity might not be buildings or tools at all, but invisible changes, shifts in the chemical composition of rocks, unusual concentrations of metals or isotopes, and residues of synthetic materials that nature cannot produce on its own. Sedimentary layers, which act as Earth's archives, can also be destroyed or altered beyond recognition. Layers that once held clear records of climate, life, and environmental conditions can be folded, tilted, and metamorphosed by the immense pressures of geological processes. What might once have been a flat sheet of rock bearing clear evidence of industrial activity, can become a distorted, mineralized fragment that reveals nothing of its original structure. And even in the rare cases where layers survive intact for tens or hundreds of millions of years, extracting meaningful evidence from them is like piecing together a book that has been shredded, burned, and scattered into the wind. The true difficulty lies in how thoroughly the planet reuses itself. The carbon in our bones, the metals in our machines, the silicon in our computers, all have been part of countless other things in the past. Earth is a master recycler, endlessly breaking down and reforming its materials. What once might have been the steel frame of a skyscraper could, given enough time, become part of a mountain range, then later erode into sand and settle on the ocean floor, before finally being drawn into the mantle to start the cycle again. This endless recycling means that unless something is preserved under extraordinarily rare and stable conditions, it will eventually vanish into the flow of geological time. All of this means that even if there had been entire civilizations with technologies as advanced as ours, or far beyond, there is every chance their physical legacy would be utterly erased. The planet's surface would look as if they had never been here, their histories dissolved into the same processes that have erased 99.9% of everything that ever lived. Only the faintest traces might remain, a subtle layer of rock with unusual chemistry, a strange pattern in the fossil record, an anomaly in the ratios of stable isotopes. These would be the whispers of something ancient and intelligent, lost to time, waiting for someone in the far future to notice and wonder. When we try to imagine discovering an ancient civilization, our minds instinctively turn to the fossil record. Fossils are our primary window into life's past, a record of organisms that lived millions, even hundreds of millions of years ago. Yet this record is far from complete. In fact, it is incredibly selective and biased, capturing only a fraction of the species that have ever existed. The fossilization process is so rare and specific that most living things vanish without leaving a trace. Flesh and soft tissue decay quickly, leaving only bones, shells, or teeth as potential candidates for preservation. Even these must be buried rapidly under the right conditions, such as sediment in riverbeds, lakes, or ocean floors before scavengers, bacteria, and the elements destroy them. Without these perfect circumstances, nothing remains. If such is the case for the countless species of animals and plants that have lived on Earth, how much more fragile would the evidence of an advanced civilization be after millions of years? For every fossil we have unearthed, there are likely thousands of species that left no fossil record at all. Many creatures lived and died in environments that did not favor preservation. Dense forests, high mountains, arid plains where remains were exposed to weather and erosion rather than buried. The result is a distorted picture of the past, one that tells us only about the rare survivors of the fossilization lottery. The same applies to any artificial materials or tools that might have existed long ago. Unless they were rapidly buried in stable conditions, they would vanish completely, their traces scattered into the environment until they became indistinguishable from naturally occurring minerals. This limitation becomes especially important when we realize that many advanced technologies would leave no obvious fossils. A stone tool might survive for thousands or even millions of years, but materials like metals, plastics, fabrics, and ceramics can break down far more quickly under natural conditions. Iron rusts and returns to the soil, copper corrodes, plastics fragment and eventually decompose under ultraviolet light or microbial activity. Ceramics can shatter into dust, over spans of time longer than the entire existence of humanity. These processes guarantee that almost nothing would be left for us to find. The few exceptions might be traces at the microscopic or chemical level, preserved in sediments or ice cores rather than in recognizable artifacts. Even when fossilization does occur, the distribution of preserved remains is patchy and uneven. Certain environments are far more likely to produce fossils than others, leading to what paleontologists call preservation bias. For example, shallow marine environments are excellent for fossilization, but that means we know much more about ancient ocean life than about the creatures that lived in mountains or rainforests. If an ancient civilization had thrived in a region that was geologically unstable, mountainous, or subject to intense erosion, the odds of preserving its remains would be even lower than for typical life forms. Whole chapters of Earth's history could vanish simply because they took place in the wrong kind of environment for long-term preservation. We also need to consider the sheer incompleteness of our exploration. Humans have only examined a tiny fraction of the Earth's surface in detail, and much of the fossil record remains buried in places we have never dug. The deep ocean floor, for example, covers more than 2/3 of the planet, yet is largely unexplored. Sediments there could hold clues to ancient events, but retrieving them requires specialized technology and a clear idea of what to look for. Even on land, vast areas remain inaccessible. Thick jungles, remote deserts, and polar ice sheets hide whatever secrets might lie beneath. If evidence of a pre-human civilization exists in these hidden places, it could remain undiscovered for centuries, or until it is lost forever to the shifting forces of the Earth. Moreover, fossils and preserved artifacts tell us nothing about the intelligence of the species they represent, unless there are clear signs of technology. The bones of a highly intelligent being might look unremarkable, offering no hint of its abilities. A bird's skull or a reptile's skeleton could belong to a creature capable of language, art, and complex social structures, but without tools or buildings to accompany them. We might never suspect its true nature. This is one of the most haunting aspects of the search for ancient civilizations. Intelligence leaves no direct fossil. We must rely entirely on indirect clues such as changes in the environment that could only result from purposeful activity. But such changes are often subtle and difficult to distinguish from natural processes. The fossil record, then, is both a treasure and a trap. It gives us glimpses of the distant past, but also hides more than it reveals. It tempts us to believe we have a clear picture when in reality we are working with fragments. Like reading a book from which most of the pages are missing and the rest are damaged beyond recognition. The story it tells is incomplete, selective, and shaped by chance. If a technologically advanced species had lived millions of years before us, there is every chance it could have left almost no visible trace in the fossil record. We might walk right over the places where its cities once stood, never realizing that under our feet lie the crushed and scattered remnants of something extraordinary. Only by looking beyond traditional fossils, searching for unusual chemical markers, isotopic anomalies, or other indirect signs, can we hope to catch even the faintest whisper of what might have come before us. If an ancient civilization truly existed millions of years ago, then the most likely evidence we could ever hope to find would not be towering ruins or preserved skeletons, but subtle and persistent signals hidden deep in the Earth's layers. These signals would not be obvious to the naked eye. They would be chemical, geological, or isotopic markers, changes in the natural composition of rocks, soils, or sediments that hint at the presence of industrial activity. Even after millions of years of erosion, tectonic shifts, and metamorphosis, some of these signals could survive in fragments, locked away in the deep archive of the planet. But identifying them would be an incredibly complex task, requiring not just careful study, but also the willingness to question whether anomalies we've already found could be the fingerprints of something intelligent. One of the clearest examples of a potential long-term signature is the alteration of isotope ratios in the atmosphere and sediments. Modern human industry is already changing the balance of carbon isotopes, specifically the ratio of carbon-12 to carbon-13, through the burning of fossil fuels, a phenomenon known as the Suez effect. This is because ancient organic matter, when burned, releases carbon with a distinct isotopic composition that differs from the carbon naturally present in the atmosphere. If another civilization had once exploited vast quantities of fossil fuels, it could have left behind a similar shift in isotope ratios that would be detectable millions of years later in layers of rock and ice. Scientists studying ancient sediments have already identified numerous isotope excursions in Earth's history. Sudden shifts in these ratios, but most are attributed to volcanic eruptions, methane releases, or other natural processes. Still, without knowing exactly what to look for, it's possible that the chemical footprint of an ancient industrial age could be hiding among these unexplained anomalies. Beyond isotopes, there are synthetic compounds, materials that do not occur naturally and are produced only through technological processes. Today, humanity is creating an enormous variety of such compounds, from industrial chemicals to plastics, pharmaceuticals, and synthetic fibers. Some of these are incredibly resistant to degradation. For example, certain plastics and fluorinated compounds might persist in some form for millions of years if buried in the right conditions. Though they may break down into smaller fragments or chemically alter over time, their unique molecular structures could remain detectable to a trained geochemist. If ancient beings had developed similar synthetic materials, traces might still be locked into sediment layers, awaiting discovery. The challenge, however, is that after so much time, these traces might be so faint and so chemically altered that we might not even recognize them as artificial. Heavy metals could also act as markers. Industrial activity tends to concentrate certain metals in quantities and combinations that are rare in nature. Mining, smelting, and manufacturing all leave behind waste products that can be absorbed into soils and sediments. Lead, mercury, cadmium, chromium, and other metals, especially when found together in unusual concentrations, might point toward technological processes. In the modern era, for example, lead pollution from gasoline and industry is already embedded in ice cores and sediments worldwide. A similar pattern, buried deep in ancient strata, could be a telltale sign that something once mined and refined the elements on a large scale. However, detecting such a pattern requires high-resolution sampling and the ability to distinguish it from the naturally occurring geological background noise. One of the more intriguing possibilities lies in the detection of unusual mineral formations that could only occur through deliberate heating, mixing, or chemical treatment, processes we associate with industrial production. Modern humans, for example, create vast amounts of concrete alloys and ceramics which, if somehow preserved and buried, might survive in altered but still recognizable forms for millions of years. Even glass, especially industrial glass used in technology, can sometimes last extremely long periods if sealed away from weathering. If buried deep and isolated from erosive forces, fragments of such materials could endure, though their original shapes and purposes would be lost, leaving only odd, inert chunks for future scientists to puzzle over. Another potential signature could be abrupt environmental changes that defy purely natural explanations. Large-scale deforestation, rapid climate shifts, mass extinctions, and sudden changes in sediment composition could all be side effects of industrial activity. For instance, the modern great acceleration of human impact on the planet, marked by skyrocketing levels of greenhouse gases, habitat loss, and biodiversity decline, will almost certainly leave a distinct layer in the geological record. A civilization millions of years in the future might notice this sharp break and wonder what could have caused it. Similarly, if a pre-human civilization had gone through its own industrial era, its activities might have triggered an analogous environmental shock, visible today as a sudden and unusual disturbance in ancient records. The ocean floor, despite its constant renewal, could also contain localized deposits of unusual material from ancient civilizations, especially in regions where sediments build up quickly and remain geologically stable for long periods. Vast undersea mining operations, chemical dumping, or the construction of massive structures could leave behind peculiar sedimentary features or chemical residues. If an aquatic or coastal civilization had existed, perhaps these deposits would be our only remaining clue to its presence. Perhaps most challenging of all is the fact that many of these signals, even if they exist, might be indistinguishable from those caused by natural phenomena. Massive volcanic events, asteroid impacts, methane hydrate releases, and even unusual biological blooms can produce isotope shifts, heavy metal deposits, and abrupt climate changes. Sorting out which anomalies are natural and which might be technological requires both scientific caution and an openness to extraordinary possibilities. Without context, an industrial signature could be dismissed as just another oddity of the planet's complex history. And yet, these subtle signs, the isotope shifts, the synthetic molecules, the heavy metal spikes, the inexplicable environmental changes, could be all that remains of a civilization that lived, thrived, and vanished before humans ever walked the Earth. They would not look like the relics we expect. They would not be grand monuments or recognizable machines. They would be whispers embedded in stone, chemical echoes of a time when something else ruled the world, traces left behind in places no one has yet thought to search. If we allow ourselves to step beyond the confines of human-centered thinking, the possibilities for what pre-human civilizations might have looked like become almost limitless. We tend to imagine intelligence in our own image, upright, bipedal, with opposable thumbs and faces capable of complex expression. But nature does not work according to human expectations. Evolution shapes life to fit its environment, and intelligence is simply one possible adaptation among countless others. It could emerge in bodies entirely unlike ours, with abilities, senses, and ways of interacting with the world that we might struggle to comprehend. If a civilization rose and fell long before our time, its members may not have resembled humans in any way. They may not have walked on two legs or even walked at all. They may have flown, swum, slithered, or crawled. Their cities might have been built underwater in dense forests or even beneath the surface of the ground. And the materials they used for their technology may have been nothing like steel, concrete, or plastic, meaning their creations could have vanished even more quickly from the geological record. The idea of a reptilian civilization, for example, is not as far-fetched as it sounds. Reptiles have existed for hundreds of millions of years and have demonstrated considerable adaptability, surviving multiple mass extinctions that wiped out other dominant life forms. Some dinosaurs, like the troodontids, are believed to have had high intelligence compared to other species of their time. If evolutionary pressures had favored brain development over sheer size or predatory strength, it is conceivable that a line of reptiles could have developed tool use, language, and complex social structures. Given millions of years, such a species might have built entire cultures potentially as sophisticated as our own. Yet if their technology relied on organic materials, or if their civilization occupied regions that were later destroyed by tectonic or volcanic activity, we might never find more than the faintest trace of their existence. Bird-like civilizations are another intriguing possibility. Modern corvids and parrots demonstrate remarkable problem-solving skills, tool use, and even the ability to understand abstract concepts. Their ancestors date back to the age of the dinosaurs, meaning intelligent, avian-like creatures could have had tens of millions of years to develop advanced behaviors and technologies, long before mammals rose to dominance. A bird civilization might have excelled at aerial construction, using lightweight materials and nesting in vast vertical structures. Such architecture could have been ephemeral by design, leaving no durable ruins for us to find. Their written language might have been carved into wood or etched into leaves, leaving behind no permanent archive. If their world was destroyed by environmental collapse or mass extinction, their entire history could vanish almost without a trace. Marine civilizations open an even wider door of speculation. The oceans cover more than 2/3 of the Earth's surface and have been home to intelligent life for hundreds of millions of years. Cephalopods like octopuses and cuttlefish already display remarkable intelligence, problem-solving abilities, and adaptability despite their relatively short lifespans. If a lineage of cephalopods had evolved greater longevity and social complexity, They could have formed highly advanced cultures deep in the seas. Their tools might have been made from coral, shell, or biodegradable materials. They could have manipulated currents, altered ecosystems, or even engineered underwater habitats on scales beyond our imagination. The ocean floor, constantly renewed and reshaped, would erase all physical traces of such a civilization within a geological heartbeat. The only remnants might be chemical changes in seawater sediments, which, after millions of years, would be almost impossible to interpret as signs of intelligent activity. It's also possible that a pre-human civilization could have been subterranean. Burrowing species have existed since the earliest days of life on land. If an intelligent underground-dwelling species had emerged, it could have built extensive networks of tunnels, chambers, and underground cities. Their entire culture might have been shielded from the surface world, making it even less likely that we would find their ruins today. Minerals from their tools and structures might have blended seamlessly with natural deposits over time, making them indistinguishable to geologists. Even if remnants of their subterranean existence still exist, they might be buried so deep that we would never encounter them without deliberate searching. Then there is the possibility that some ancient civilizations may have looked nothing like animals as we know them. Intelligence could emerge in forms that challenge our basic assumptions. Gelatinous, plant-like beings capable of slow but deliberate movement. Colony organisms composed of many smaller, specialized individuals functioning as a single mind. Or even life forms that do not rely on carbon-based chemistry at all, though such speculation moves us closer to the realm of science fiction. The important point is that intelligence is not tied to any one physical form or set of characteristics. It is an adaptation to environmental challenges, and as such, it could take root in any number of evolutionary paths. The environments these civilizations inhabited would have shaped their culture and technology in profound ways. A civilization in a humid, tropical world might favor architecture, built from living plants, weaving homes and public spaces into the forest canopy. A species in a desert environment might build from sand and clay, constructing intricate underground reservoirs and heat-reflective surfaces. In icy regions, entire cities could be carved into glaciers, their walls and roofs made of transparent ice that refracts light in dazzling patterns. Each of these materials is fragile in geological terms, meaning their destruction over millions of years would be inevitable. Perhaps the most unsettling thought is that such civilizations might not have needed to build permanent monuments at all. Human culture is deeply tied to physical records, books, inscriptions, buildings, but another intelligent species might have relied entirely on oral tradition, transient art, or biological memory storage within their own bodies. Their achievements could have been shared, celebrated, and passed down without ever leaving behind a durable artifact. When they disappeared, nothing tangible would remain, making their existence invisible to anyone who came after. The Earth would move on, carrying their story and cinder, while a new species rose to believe it was the first to walk a path of intelligence and ambition. When imagining the possibility of multiple civilizations across Earth's history, our thoughts often default to land-based societies like our own. But the oceans, vast and ancient, present an entirely different and perhaps even more compelling scenario. Covering more than 2/3 of the planet's surface, they are the cradle of life itself, home to countless evolutionary experiments that have unfolded over hundreds of millions of years. For most of Earth's history, the seas were the dominant arena for complex life. If intelligence and civilization emerged in the distant past, it may well have arisen beneath the waves in places that we have barely begun to explore even today. Such a civilization could have flourished entirely out of view of terrestrial life, building cities not on dry land, but on continental shelves in deep ocean basins or within intricate coral structures that dwarfed even our largest human constructions. The advantages of an oceanic civilization are striking. The sea offers a three-dimensional living space, abundant resources, and natural protection from many land-based catastrophes. Meteor impacts, wildfires, and droughts, events that can devastate surface civilizations, would have far less impact on a species adapted to life in the deep. Underwater settlements could have been crafted from coral-like materials, volcanic rock, or engineered biostructures blending seamlessly with the surrounding environment. Advanced marine species could have developed methods to cultivate food through kelp farming, manage large-scale breeding grounds for prey animals, or even manipulate ocean currents to create nutrient-rich zones. The ocean's chemical and thermal gradients might have been harnessed for power, long before humans ever learned to generate electricity. But this watery domain also presents an enormous problem for the preservation of evidence. The ocean floor is not static. It is constantly renewed through plate tectonics as new crust emerges from mid-ocean ridges and old crust is consumed in subduction zones. This means that even if entire underwater cities once existed, their remains would eventually be drawn deep into the Earth's mantle and erased completely. In many cases, this recycling process would take far less time than the millions of years, separating us from a hypothetical ancient marine civilization. Even in geologically stable areas like deep sedimentary basins, the immense pressure, chemical reactions, and slow but steady accumulation of silt would bury and transform any remains until they were indistinguishable from natural formations. There is also the challenge of recognition. The oceans teem with life that already creates massive and complex structures. Coral reefs, shell mounds, and sponge colonies can look astonishingly architectural to the human eye. If an ancient civilization left behind similar constructions, the line between biology and technology could blur to the point where we might misinterpret engineered structures as natural phenomena. Similarly, chemical residues in sediment might be dismissed as the result of algal blooms, hydrothermal vents, or volcanic activity, when in reality they could be the leftovers of industry. The deeper the layer of sediment, the harder it becomes to distinguish a deliberate pattern from a quirk of nature. A marine civilization might also have developed technologies fundamentally different from ours. Technologies designed for a fluid, high-pressure world. They may have used sound as their primary medium for communication and construction, shaping environments with powerful acoustic tools. Light, difficult to use in deep waters, might have been replaced by bioluminescence, either engineered or cultivated in symbiosis with other organisms. Structures could have been living entities grown from genetically modified corals or sponges, designed to expand and repair themselves over time. Such achievements would leave little behind after their creators vanished. The bioengineered forms would eventually be consumed by the same natural cycles that had sustained them. It is also possible that an oceanic civilization never felt the need to colonize the land. For humans, moving from water to land was a defining step in our evolutionary history. But for a species fully adapted to the sea, land might have been inhospitable or simply unnecessary. If they remained entirely aquatic, their influence on terrestrial ecosystems might have been minimal, leaving no clear signs in the fossil record of land-based life. Their legacy would have been contained entirely within the shifting, eroding seafloor, a place where geological processes work against preservation far more aggressively than on land. Yet there are small windows where traces might survive. Coastal regions that were once submerged but later uplifted by tectonic activity could, in theory, preserve the remnants of ancient harbors, breakwaters, or other engineered features. These could be buried under layers of rock and sediment, waiting to be discovered. Similarly, certain deep-sea trenches and isolated basins can remain geologically stable for longer periods, potentially holding undisturbed sediment layers dating back tens of millions of years. If we were to core these sediments with enough precision, we might detect chemical or physical anomalies, perhaps elevated levels of metals, unusual isotopes, or the presence of synthetic compounds that could hint at past industrial activity. Even today, our knowledge of the ocean is astonishingly incomplete. It is often said that we know more about the surface of the moon than about the deep sea floor. Vast stretches of the ocean remain unexplored, and many parts of the seafloor have never been mapped in high detail. If an ancient marine civilization existed, its most enduring monuments might still lie hidden in deep canyons, under thick blankets of sediment, or encased in mineral deposits formed over millions of years. The difficulty lies in recognizing such remnants for what they are. Without context, they might be filed away as oddities. Interesting, perhaps, but not proof of intelligence. The thought of an ocean-based civilization raises another question. What if their disappearance was not the result of natural disaster, but of choice? An advanced species might have reached a point of understanding where expansion, consumption, and technological dominance no longer served them. They could have deliberately dismantled their cities, recycled their materials, and returned to a simpler way of life, leaving almost nothing for the future to find. Over millions of years, the ocean's currents and life cycles would erase even the faintest traces of their existence, until all that remained was the living ocean itself, unaware of the story it had once carried. If we were to go looking for the remnants of an ancient civilization that predates humanity by millions of years, we would not expect to find intact buildings, recognizable tools, or preserved scrolls. Those would have long since been destroyed or transformed by the planet's unrelenting cycles. Instead, our search would have to focus on far subtler, more enduring signs, traces embedded in the geological record that could survive immense spans of time. Among the most promising of these potential markers are the kinds of materials and chemical residues that could only have been created through advanced technological processes. If such markers were discovered in ancient rock layers, far older than our species, they might serve as the only whispers of an intelligence that once shaped the Earth. One possibility is the detection of unusual concentrations of synthetic chemicals, substances that do not occur naturally and require deliberate manufacture. Today, humanity is producing an array of these materials on a massive scale: plastics, industrial solvents, pesticides, and a host of synthetic polymers. While many of these will eventually degrade, some have remarkable stability under the right conditions. Certain halogenated compounds, for example, are resistant to chemical breakdown and could persist in sediments for millions of years. If a long-vanished civilization had used similar materials, traces might still be locked in the microscopic pores of ancient rocks or deep-sea clays, invisible to the casual observer, but detectable with precise chemical analysis. Similarly, specific metals and alloys could be telltale indicators. The processes of mining, smelting, and refining leave distinct patterns in the environment, anomalous concentrations of certain metals, sometimes in ratios that do not occur naturally. For instance, modern human activity has introduced large amounts of lead, mercury, cadmium, and chromium into soils and sediments across the globe. If we encountered a similar pattern in a rock layer dating back tens of millions of years, with no natural explanation, it might point to technological extraction and use of those elements. Even if the original objects had long since corroded or been transformed by geological forces, the chemical signature of their manufacture could still remain. Another intriguing possibility lies in the presence of exotic materials that would not form under normal planetary conditions. Our own civilization has created advanced ceramics, high-performance composites, and superalloys designed to withstand extreme temperatures and pressures. Over time, many of these materials would break down, but some might leave microscopic residues that betray their artificial origin. Even the byproducts of nuclear activity, certain isotopes with long half-lives could, in principle, survive for millions of years if trapped in the right geological environment. A sudden, unexplained spike in these isotopes within an ancient layer could serve as an unmistakable sign that something extraordinary had happened, something beyond the scope of natural processes. Plastic, in particular, offers a unique avenue of investigation. In the modern era, plastic waste has infiltrated every corner of the planet, from the deepest ocean trenches to the highest mountain peaks. Over time, larger plastic objects break down into microplastics and eventually into nanoplastics, which can become incorporated into sediments. Given the right burial conditions, isolated from sunlight, oxygen, and microbial activity, plastic particles could endure for immense spans of time. If, in the far future, a geologist were to drill into rock and discover microplastic-like particles in a layer millions of years old, it would raise questions that could only be answered by considering the possibility of an ancient industrial civilization. We should also consider the possibility of abrupt chemical shifts in the atmosphere or oceans that cannot be explained solely by natural events. Industrial activity on a large scale inevitably alters the environment. Today, our burning of fossil fuels is driving a rapid rise in carbon dioxide levels, which will leave a distinct isotopic signature in the geological record. Other pollutants, nitrogen oxides, sulfur compounds, and heavy metals, are likewise becoming embedded in soils and sediments. A civilization millions of years ago might have left behind similar chemical fingerprints, which we could detect today as anomalies in ancient layers. These shifts might be accompanied by sudden changes in the fossil record, such as abrupt extinctions or the appearance of species adapted to altered environmental conditions. Interestingly, some ancient anomalies in Earth's history do raise questions. Paleoclimatic records reveal events where temperatures rose dramatically in short periods, oceans became acidified, and large portions of the biosphere were disrupted. Most of these events have plausible natural explanations: massive volcanic eruptions, asteroid impacts, methane hydrate releases, but it remains possible, however unlikely, that at least some could have been triggered by the industrial activity of a now vanished civilization. Without direct evidence, the hypothesis remains speculative, but the search for these patterns is precisely the kind of investigation the Silurian Hypothesis encourages. Even the simple act of quarrying or large-scale land alteration can leave detectable marks. In the modern world, human mining operations are reshaping entire landscapes, stripping away hillsides, creating vast pits, and leaving behind layers of waste rock and tailings. These deposits have distinctive compositions, different from anything produced by natural erosion. In the distant future, after millions of years of burial, such layers could fossilize into unusual rock formations, betraying their artificial origin to a sufficiently curious investigator. If an ancient civilization had engaged in similar large-scale resource extraction, their quarries might still exist somewhere beneath our feet, though so altered by time that they would be unrecognizable without detailed study. One of the most challenging aspects of this search is that all of these potential markers, plastics, metals, synthetic compounds, isotopic anomalies, could also have natural analogs. Nature, after all, is capable of producing a bewildering variety of chemical and geological phenomena. Distinguishing an artificial signature from a natural one requires context, pattern recognition, and the elimination of alternative explanations. A single anomaly might be dismissed as coincidence, Multiple overlapping anomalies in the same geological layer would be far harder to ignore. If we were to find such overlapping patterns in rock strata far older than humanity, we would be faced with an extraordinary possibility that we are not the first species to alter the planet on an industrial scale. In that moment, the deep past would open up before us in a new and unsettling way. The planet's history would no longer seem like a linear story leading inevitably to us, but a repeating cycle of rise and fall, with each great civilization leaving behind only the faintest, most cryptic clues to its passing. Throughout Earth's history, life has been repeatedly interrupted by catastrophic events, so immense that they reshaped the entire trajectory of evolution. These events, known as mass extinctions, are the great reset buttons of the planet's story, wiping out dominant species and opening ecological niches for new forms of life to rise. From a geological perspective, they are sudden and devastating, often occurring in the space of just a few thousand years or even less. For any civilization unlucky enough to exist during such a time, these events would not just be environmental challenges. They would be existential threats capable of erasing almost every trace of their existence. When we think about the possibility of ancient civilizations predating humanity, we must consider the role of these planetary catastrophes in obliterating their legacies. One of the most famous examples is the Cretaceous-Paleogene extinction event, 66 million years ago, when an asteroid at least 10 kilometers wide struck what is now the Yucatan Peninsula. The energy released was equivalent to billions of nuclear bombs, generating shockwaves, wildfires, and tsunamis on a global scale. Dust and aerosols filled the atmosphere, blocking sunlight for months or even years, plunging the world into a prolonged darkness. Photosynthesis halted, food chains collapsed, and roughly 75% of all species vanished. If an advanced civilization had existed in that era, whether on land, in the oceans, or both, the immediate destruction from the impact and the ensuing environmental collapse would have been almost impossible to survive. Their cities would have been obliterated by blast waves, buried under layers of ejecta, or swept away by mega tsunamis. Whatever fragments remained would soon be overrun by the new, rapidly changing ecosystems that followed. But asteroid impacts are only one type of mass extinction trigger. Volcanism on an enormous scale can be equally destructive, as seen in the Permian-Triassic extinction event, the most severe known in Earth's history, which occurred about 252 million years ago. Vast volcanic eruptions in what is now Siberia unleashed massive quantities of lava, ash, and gases over hundreds of thousands of years. The release of carbon dioxide and methane drove global temperatures to extremes, acidified the oceans, and depleted oxygen levels in the seas to the point where most marine life perished. On land, intense heat and toxic gases made survival difficult for even the hardiest species. An industrial civilization facing such conditions would have been powerless to prevent the cascading chain of disasters. Crop failures, poisoned water supplies, and the collapse of both terrestrial and marine ecosystems. Over millions of years, the volcanic rock would bury whatever was left of their technology, entombing their history beneath hundreds of meters of basalt. Climate itself can also shift rapidly and destructively without a single massive event. Episodes like the Paleocene-Eocene thermal maximum around 56 million years ago saw sudden global warming of 5 to 8 degrees Celsius in just a few thousand years, fast enough to cause widespread extinctions and major changes in ecosystems. Even smaller climatic shifts have spelled doom for human civilizations in recorded history, such as the collapse of the Norse settlements in Greenland during the Little Ice Age. For a prehistoric civilization living in an age of rapid warming or cooling, such instability could have been catastrophic. Agricultural systems might fail, sea levels could rise or fall dramatically, and regions once habitable could become unlivable in a matter of centuries. If they lacked the technological means to adapt, or if their infrastructure was too dependent on stable climate patterns, they could vanish within a few generations, leaving almost no durable record of their passing. Another form of extinction driver comes from within the biosphere itself. The evolution of new, highly successful species can disrupt existing ecosystems in unpredictable ways. In the Great Oxidation Event over 2 billion years ago, the proliferation of photosynthetic microorganisms transformed Earth's atmosphere, releasing oxygen that was toxic to many existing life forms at the time. Entire microbial ecosystems collapsed in the face of this pollution from a new form of life. While this event predates the evolution of complex multicellular organisms, it's a reminder that even biological processes can bring about planetary-scale change. A civilization living through a similar biogenic upheaval, perhaps triggered by its own genetic engineering or by natural evolutionary pressures, could find itself overwhelmed by environmental transformations it did not anticipate. The ocean, too, has been the stage for devastating extinction pulses. Anoxic events where oxygen levels in the water drop sharply have occurred multiple times in Earth's history, often linked to volcanic activity or climatic shifts. These events can cause mass die-offs in marine environments, eradicating the base of the food chain and leading to cascading extinctions. For a marine-based civilization, such a catastrophe would be equivalent to the collapse of the entire biosphere. With their food sources gone and their environment turned into a suffocating wasteland, survival would be nearly impossible. In the geological record, these events are visible as dark, organic-rich layers in marine sediments. Layers that, in theory, could also contain chemical fingerprints of industrial activity if such civilizations had existed. Even without global-scale disasters, regional catastrophes could eliminate entire cultures. Supervolcano eruptions like the Toba event 74,000 years ago release ash and gases capable of altering the climate for decades, causing famines and societal collapse. Earthquakes, tsunamis, and landslides can destroy coastlines and river valleys where civilizations often concentrate. Over time, repeated regional disasters could wipe away population centers faster than they could be rebuilt, leading to the gradual fading of a civilization into extinction. The combined effect of these forces is a planet that is constantly reshaping itself, sometimes gradually, sometimes violently, but always without regard for what came before. For an ancient civilization, even one as technologically advanced as we are now, a mass extinction would be the ultimate eraser. Within decades, their infrastructure would crumble. Within centuries, their cities would be reduced to rubble. Within millions of years, even the rubble would be gone, replaced by new geological formations. What would remain are only the most durable and geochemically persistent markers. A spike in certain isotopes, an unusual layer of sediment, a brief interruption in the fossil record. These faint traces, buried deep in time, could be all that survived of a species' entire history. For the rest of the planet, life would simply begin again, filling the empty niches, evolving into new forms and continuing the cycle that has defined Earth for billions of years. One of the most intriguing patterns in the history of life on Earth is that change does not always happen gradually. While evolution often works in slow increments, there are periods when the diversity and complexity of life suddenly explode, as if the planet has leapt forward in creativity. These bursts are visible in the fossil record as moments when new species appear in great numbers and new body plans emerge seemingly out of nowhere. The most famous of these is the Cambrian explosion, around 541 million years ago. when almost every major group of complex animals appeared within a relatively short geological window. Before this period, life was dominated by simple, soft-bodied organisms, but within just tens of millions of years, the seas were filled with an astonishing variety of creatures: trilobites, early mollusks, sponges, and the first predators with hard shells and grasping appendages. To scientists, this remains one of the great mysteries of biology. Why did life diversify so dramatically and so suddenly at this point in time? Most explanations for events like the Cambrian explosion focus on natural causes. Shifts in climate, rising oxygen levels, and the evolution of key genetic innovations, such as the ability to form hard skeletons, all likely played a role. But in the context of the Silurian hypothesis, another possibility, more speculative yet deeply fascinating, emerges. What if some of these bursts of biodiversity were not entirely natural? What if they were, in some small way, influenced by the actions of an earlier intelligent civilization? If such a species had existed millions of years before the Cambrian, it might have experimented with its environment in ways that left no obvious technological traces, but did leave a profound biological legacy. This idea does not require imagining ancient beings seeding the earth with entirely alien creatures. Even modest interventions in ecosystems could have far-reaching consequences over geological time. A civilization with advanced knowledge of biology might engage in selective breeding of certain species, intentional or accidental relocation of organisms to new environments, or even genetic modification. If these activities occurred on a large enough scale, they could trigger evolutionary chain reactions that permanently altered the trajectory of life. Over millions of years, natural selection would refine these changes, erasing the fingerprints of their origin, until all that remained was the appearance of an abrupt evolutionary leap. The Cambrian explosion is not the only event in Earth's history that invites such speculation. Later periods also saw sudden proliferations of life. After the Permian-Triassic extinction, the most severe extinction event known, life rebounded with remarkable speed and variety, eventually leading to the rise of the first dinosaurs and mammals. Following the asteroid impact that ended the Cretaceous period, mammals rapidly diversified into forms that would dominate the next 66 million years. While these recoveries are typically explained by the opening of ecological niches after mass die-offs, one could imagine a civilization playing a subtle role, perhaps accelerating recovery through targeted reintroductions of species or by manipulating the environment to favor certain life forms. Even changes that appear purely geological might mask biological influences. Large-scale shifts in nutrient cycles, such as sudden increases in oceanic phosphorus or nitrogen, can drive population booms in certain species, leading to cascading effects throughout the food web. On a smaller timescale, human agriculture is already an example of this. By concentrating nutrients, clearing land, and cultivating specific plants and animals, we have altered ecosystems worldwide. If an ancient civilization had done something similar, perhaps on a marine scale, it might have left behind chemical and fossil evidence that would be indistinguishable from certain natural phenomena. Then there are the more enigmatic anomalies in the fossil record, where species appear without clear precursors, or where complex features emerge far earlier than expected. The origins of certain groups of flowering plants, for instance, remain puzzling, as does the sudden appearance of large-bodied predators in some prehistoric ecosystems. While most of these puzzles can eventually be explained through the incompleteness of the fossil record or through newly discovered transitional forms, a few may always remain ambiguous, their origins lost in the haze of deep time. For those willing to consider the possibility, such mysteries could be the evolutionary echoes of a vanished intelligence. It is important to note that any influence of this kind would not be obvious to future scientists without direct evidence. The passage of hundreds of millions of years would dissolve almost every physical artifact, and DNA from those times would be so degraded as to be unrecoverable. The changes in the fossil record would appear entirely natural, because by the time we observe them, they would have been shaped and molded by countless generations of subsequent evolution. Just as our own actions, introducing invasive species, changing global temperatures, altering habitats, will leave a legacy that will seem natural to any distant future observer, so too could the activities of a long-lost civilization blend invisibly into the fabric of Earth's history. The Cambrian explosion and other bursts like it are reminders of how rapidly the planet can transform and how quickly entirely new forms of life can arise. Whether these events were purely the result of natural processes or whether they could have been nudged, however slightly, by the hand of intelligence, they stand as milestones in the story of life. They show that the pace of change is not constant, that evolution can sprint as well as crawl, and that in the vast theater of Earth's history, there may have been moments when the curtain was pulled back not only by geology and climate, but perhaps by the deliberate choices of beings who have long since disappeared into the shadows of deep time. When we study the climate shifts of Earth's past, we are looking at one of the most revealing and enduring records of the planet's history. Changes in temperature, atmospheric composition, and ocean chemistry are written into layers of ice, trapped in bubbles of ancient air and etched into the sediments of the sea floor. These climate records often stretch back tens of millions of years, capturing moments of dramatic transformation, periods when the world warmed or cooled with startling speed, when ice sheets expanded or vanished, when seas rose high enough to drown entire continents or fell low enough to expose vast new lands. Most of these changes have clear natural causes: volcanic eruptions, variations in Earth's orbit, shifts in ocean currents, or the after-effects of asteroid impacts. But some climate events stand out as particularly sudden and intense, so abrupt that they prompt the question: could they, at least in part, have been triggered by intelligent activity? Our own civilization is an undeniable example of how rapidly intelligent life can alter the planet's climate. In just over a century, human industry has transformed the chemical composition of the atmosphere, raising carbon dioxide concentrations to levels not seen in millions of years. We have altered the reflectivity of Earth's surface by changing forests into farmland and cities. We have redirected rivers, drained wetlands, and acidified the oceans through the burning of fossil fuels. These actions are producing a geological fingerprint, a set of chemical and biological changes that will be detectable millions of years from now. If we can do this in such a short time, it is not unreasonable to wonder whether another species could have done something similar long before we appeared. In the geological record, some ancient climate events bear an uncanny resemblance to the kind of shifts we are causing today. One of the most studied is the Paleocene-Eocene thermal maximum, PETM, about 56 million years ago. During this event, global temperatures rose by at least 5 degrees Celsius in just a few thousand years, a blink of an eye in geological terms. The oceans became more acidic, and there were major disruptions in ecosystems worldwide. The cause is usually attributed to a massive release of greenhouse gases, perhaps from volcanic activity or the destabilization of methane hydrates in the ocean. Yet the exact trigger remains uncertain. If an industrial civilization had existed in that era and burned large quantities of carbon-based fuels, the resulting isotopic signature in the rock record might look very much like what we see from the PETM. Without additional evidence, distinguishing between a natural and an artificial cause would be almost impossible. Other climate anomalies present similar puzzles. The mid-Miocene climatic optimum, about 15 million years ago, saw a pronounced warming period, while episodes of sudden cooling, like the Younger Dryas roughly 12,800 years ago, show how quickly the Earth's climate can swing in the opposite direction. These shifts can occur within centuries or even decades, and their causes are not always fully understood. Some involve complex feedback loops, where a small initial change, such as a shift in ocean circulation, can cascade into a planet-wide transformation. If an intelligent species had altered the environment for its own purposes, whether through energy use, agriculture, or geoengineering, the resulting changes might be indistinguishable from such natural feedback processes when viewed millions of years later. The impact of agriculture alone, for example, can be profound. In our own case, large-scale farming has not only transformed landscapes but has also released enormous amounts of carbon into the atmosphere from soil disturbance and deforestation. A pre-human civilization practicing its own form of intensive agriculture, whether on land or in the sea, could have driven similar climate shifts even without an industrial revolution. By clearing forests, irrigating deserts, or cultivating vast monocultures, they might have altered rainfall patterns, changed atmospheric dust levels, and influenced global temperatures. Over thousands of years, these changes would accumulate into a climate signal that could still be visible in geological records today. Ocean chemistry provides another potential clue. The modern phenomenon of ocean acidification, driven by the absorption of excess atmospheric CO2, will leave behind distinct chemical signatures in marine sediments. If ancient civilizations had released large quantities of CO2 or other gases into the atmosphere, their effects on ocean pH and carbonate chemistry could also persist in the fossilized shells of marine organisms. Similarly, large-scale pollution from industrial processes, metals, synthetic chemicals, or isotopes could settle into sediments and remain locked there for millions of years, forming a chemical horizon recognizable to future scientists. Some have even speculated about climate anomalies driven by deliberate planetary engineering. Advanced civilizations might attempt to cool their world by increasing its reflectivity, spreading reflective particles in the atmosphere, or constructing vast orbital structures to shade the planet, or to warm it by releasing greenhouse gases during a natural ice age. These interventions, if undertaken on a large enough scale, would leave behind signals in the geological and chemical record. Unusual particle deposits, unexpected isotope ratios, or shifts in sedimentation patterns inconsistent with known natural drivers. Over deep time, the physical structures involved would vanish, but the environmental changes they caused might endure. What makes this line of thought particularly compelling is that our own activity has already begun to create a distinctive techno-signature in the climate record. Future geologists studying rocks from our time will see a sudden, sharp change in greenhouse gas levels, global temperatures, ocean chemistry, and biodiversity. They will find plastic fragments preserved in sediments, artificial chemicals that nature never produced, and a spike in the presence of certain heavy metals. They might also see abrupt extinctions, changes in plant pollen distribution, and altered sediment layers from damming and rerouting rivers. To a species living millions of years from now, these clues could be as puzzling as some of the ancient anomalies we currently struggle to explain. The past is filled with climatic mysteries. We can account for many of them, but some remain uncertain. Spikes and drops in temperature, sudden shifts in atmospheric composition, inexplicable changes in the distribution of life. Each of these could be the fingerprint of an unusual natural event. or the ghostly echo of a long-vanished civilization's environmental footprint. Without direct evidence, the question remains open, but the record of Earth's climate is clear on one point. Intelligent life, if it appears, has the power to change an entire planet, and those changes can last long after the species itself has faded into oblivion. When we examine the fragility of human civilization, it becomes apparent that even the most advanced societies are not immune to collapse. We tend to think of our cities' infrastructure and knowledge as permanent, but history is filled with examples that prove otherwise. The great empires of the past, Rome, the Maya, the Indus Valley, Mesopotamia, once flourished with complex economies, monumental architecture, and intricate social systems. Yet each eventually fell, sometimes over centuries, sometimes in a matter of decades. Their collapses were driven by a combination of factors: environmental changes, resource depletion, internal political instability, warfare, and disease. What remains of them today are scattered ruins, fragments of writing, and artifacts that archaeologists painstakingly piece together into partial stories. Now imagine extending that same vulnerability over the vast sweep of geological time. A civilization that existed millions of years ago would not only have had to face the threats that we know, but also the far greater and more unpredictable hazards of a planet constantly reshaping itself. Part of the danger lies in the interconnected nature of complex societies. The more advanced and interdependent a civilization becomes, the more sensitive it is to disruptions in its systems. In our own case, global supply chains, energy networks, and digital infrastructures link every part of our world. A failure in one key sector, whether due to environmental disaster, cyber attack, or political upheaval, can have cascading effects that ripple across the entire system. For an ancient civilization, similar vulnerabilities would have existed in whatever form their infrastructure took. If they relied on large-scale agriculture, a climate shift or crop disease could have sparked famine. If they depended on particular mineral resources, the exhaustion or inaccessibility of those deposits could have crippled their economy. If their technology required constant maintenance, any major disruption, natural or man-made, could have led to irreversible decline. Another threat comes from the environment itself. Even in stable periods, Earth's climate can change enough to make entire regions uninhabitable. Desertification, flooding, prolonged droughts, or sudden freezes can drive populations to migrate, causing conflict over resources and destabilizing governments. For civilizations that reached global scales, such shifts could have threatened food security on a massive level. For smaller, regionally concentrated civilizations, a single catastrophic event, such as a supervolcano eruption or asteroid impact, could have been enough to wipe them out entirely. If their population was reduced to a small remnant, the cultural and technological knowledge they had accumulated might not have been passed on, leading to a reversion to simpler ways of life within a few generations. War is another recurring cause of collapse in human history, and it could just as easily have played a role in the disappearance of a prehistoric civilization. With advanced technology comes advanced weaponry, and with that comes the potential for self-destruction. It is possible that a past civilization might have engaged in conflicts so destructive that they left little standing. The use of large-scale incendiary weapons, for example, could have reduced cities to ash. Chemical or biological weapons could have decimated populations, and in the most extreme case, nuclear war could have left behind only faint isotopic traces detectable millions of years later. Without survivors capable of maintaining infrastructure and knowledge, even the most sophisticated society could crumble in remarkably little time. Disease, too, has been a silent force of collapse. In human history, pandemics such as the Black Death and the Spanish flu have reshaped societies, killed millions, and altered the course of civilizations. An advanced civilization in the distant past might have been vulnerable to similar outbreaks, perhaps from natural pathogens or from diseases inadvertently created through their own biological research. If these diseases were widespread enough, they could have triggered social breakdown and economic collapse, leaving a diminished population struggling to survive. In the absence of written records or preserved biological material, such events would be invisible to us today. There is also the possibility of collapse through gradual decline rather than sudden catastrophe. Civilizations can fail simply by exhausting the resources they depend on. Deforestation, soil depletion, overfishing, and water shortages have all contributed to the downfall of societies in our own history. If a prehistoric civilization overexploited its environment, whether on land or in the oceans, it could have reached a tipping point where recovery was no longer possible. Without the resources to sustain its population or maintain its technology, the civilization might have slowly dwindled, with knowledge and cultural achievements fading over centuries until they were forgotten entirely. In considering these scenarios, it is sobering to realize how little would remain of a fallen civilization after millions of years. Even without a dramatic extinction event, the remnants of their cities and industries would gradually be reclaimed by nature. Plants, animals, and microbes would break down structures, wind and water would erode monuments, earthquakes would shatter and bury buildings. Within a few thousand years, most visible traces would be gone. After millions of years, the land itself would have shifted, and any surviving evidence would be locked deep underground or transformed beyond recognition. The fragility of civilizations also means that even if multiple advanced societies arose over the course of Earth's history, their timelines might not overlap. There could have been vast stretches of time when the planet had no intelligent technological species at all, only for another to emerge millions of years later, unaware that it was not the first. This cycle of rise and collapse could have repeated itself many times, with each civilization leaving behind only the faintest geological and chemical hints of its existence. And just as we look to our past and see ourselves as unique, those civilizations would have thought the same, never imagining that they too might one day be forgotten. When we think about the Silurian Hypothesis in the context of Earth's history, it is natural to wonder whether such questions should be limited to our own planet. The conditions that might allow for the rise and fall of civilizations are not unique to Earth. If life is a common outcome in the universe, and if intelligence is one possible evolutionary path, then the idea of civilizations rising, flourishing, and disappearing could apply equally well to other worlds. This means that the search for multiple civilizations in Earth's past naturally extends into a broader, almost cosmic perspective. The possibility of parallel histories unfolding on neighboring planets like Mars and Venus, or even on moons such as Europa or Titan. Mars is perhaps the most tempting candidate for this kind of speculation. Today, it is a cold, dry, and seemingly lifeless world, its surface battered by billions of years of asteroid impacts and stripped of much of its atmosphere. But the evidence that Mars once had liquid water, rivers, lakes, and possibly even oceans is overwhelming. Ancient river valleys wind across its surface, deltas sit frozen in time, and minerals that form only in the presence of water have been detected across the planet. In its distant past, Mars may have been warmer and wetter with a thicker atmosphere capable of supporting stable bodies of water for millions of years. If life arose there as it did on Earth, then it is at least conceivable that it had enough time to evolve intelligence. A Martian civilization might have developed its own tools, culture, and technology, perhaps entirely differently from ours. Yet given the geological and atmospheric changes Mars has undergone, any such civilization could have been erased. Wind-blown dust has buried much of the surface under layers of sediment, and without plate tectonics to recycle the crust, the planet's surface is ancient but constantly weathered by micrometeorites and dust storms. The ruins of cities, if they ever existed, could be worn down to unrecognizable forms or hidden beneath layers of dust meters thick. Venus presents an even more dramatic case of planetary transformation. Today, its surface is a hellscape of crushing atmospheric pressure and temperatures hot enough to melt lead, with clouds of sulfuric acid swirling high above. But billions of years ago, Venus may have been a very different place. Some climate models suggest that it could have had temperate conditions and even liquid water oceans for a significant period. If that is true, it might once have been habitable to life as we know it, and possibly to civilizations. The tragedy of Venus is that it underwent a runaway greenhouse effect, perhaps triggered by massive volcanic outgassing, which transformed it from a potentially life-supporting world into the extreme environment we see today. If intelligent beings had thrived there, the planet's transformation would have obliterated nearly all surface evidence. Venus's entire surface appears to have been resurfaced by volcanic activity hundreds of millions of years ago, effectively erasing geological history older than that. The only clues that might remain could be in the planet's atmosphere, chemical traces or isotope ratios that deviate from natural patterns, perhaps a faint echo of industrial activity before the planet became uninhabitable. Even some of the moons in our solar system invite speculation. Europa, a moon of Jupiter, is covered in a thick shell of ice, beneath which lies a vast subsurface ocean. This ocean, warmed by tidal heating from Jupiter's immense gravity, may have existed for billions of years, long enough for life to evolve, and possibly even intelligence. If a civilization developed there, it would have been aquatic, building its society beneath an impenetrable layer of ice. Such a culture might have harnessed geothermal vents for energy, cultivated deep-sea life for food, and developed technologies suited to a pressurized, dark environment. But from our perspective on the surface, Europa's icy crust would hide everything, leaving no sign visible from space. Only by drilling through kilometers of ice or detecting unusual chemical signals venting into space could we hope to find evidence. Titan, Saturn's largest moon, offers a different kind of environment, a world with lakes and rivers not of water but of liquid methane and ethane. Its thick atmosphere and complex organic chemistry make it one of the most Earth-like bodies in the solar system, despite its frigid temperatures. Here, life, if it exists, might be based on entirely different chemical principles. A civilization on Titan could have adapted to extreme cold, building with materials that would be fragile on Earth but strong in Titan's deep freeze. Their technology might look nothing like ours, perhaps reliant on chemical processes unfamiliar to terrestrial science. If such a civilization had existed in Titan's distant past and then vanished, the slow geologic and atmospheric changes on the moon might preserve its traces far longer than Earth's active geology would allow. But identifying those traces would require us to understand technologies born in an alien context. Extending the Silurian Hypothesis to other worlds forces us to confront the likelihood that civilizations, if they arise, are temporary phenomena. Even a species that achieves technological mastery cannot escape the slow inevitabilities of planetary change. Climate shifts, asteroid impacts, geological upheavals, and the eventual evolution of its star. Just as Earth's surface and atmosphere erase the signs of its own past over time, so too would other planets and moons bury or destroy the relics of their histories. It is entirely possible that Mars, Venus, Europa, or Titan could have hosted intelligent beings long before Earth's human era, and that they too are now nothing more than geological whispers. This broader perspective also reframes how we think about our own civilization. If we imagine visiting Mars or Venus millions of years after a hypothetical civilization's demise, and finding only a few ambiguous chemical signatures or strange mineral deposits, we must accept that the same could happen here. Future visitors to Earth, arriving tens of millions of years from now, might find only a thin layer of rock enriched with certain metals, plastics, and isotopes, and wonder, briefly, what kind of beings could have left such a peculiar mark before vanishing forever. One of the most persistent beliefs in human culture is that we are the pinnacle of evolution, the inevitable and ultimate product of life's long history on Earth. This view, deeply ingrained in our thinking, encourages us to see ourselves as unique and irreplaceable, the first and only species to develop intelligence and technology on a planetary scale. It is a comforting idea, one that reinforces our sense of purpose and importance. But it is also a dangerous assumption, because it blinds us to the possibility that we may simply be part of a repeating cycle. A cycle in which advanced civilizations rise, flourish, and vanish, leaving behind only faint geological traces. The danger of this belief is not only that it limits our imagination, but that it fosters complacency, making us less willing to learn from the mistakes that could have ended earlier civilizations before us. This sense of human exceptionalism is reinforced by the fact that we see no obvious competitors in our own history. The fossil record, as incomplete as it is, shows no clear evidence of advanced tool-making species predating humans by millions of years. Archaeology, limited to the relatively recent past, finds nothing that points to pre-human cities or technologies. To most people, this absence of evidence is interpreted as evidence of absence. If other civilizations had existed, surely we would have found something by now. But this reasoning ignores the enormous timescales involved and the destructive power of geology. The Earth's surface is not a static museum. It is a constantly changing, eroding, and recycling system that would erase almost any trace of an ancient civilization long before we had a chance to discover it. The apparent emptiness of the past may be an illusion born from the impermanence of physical evidence. Assuming we are the first intelligent species also skews how we interpret anomalies in Earth's history. Sudden climate shifts, unusual isotope ratios, or abrupt changes in biodiversity are nearly always attributed to natural causes because we cannot imagine a technological agent existing in those times. Even when we find patterns that mirror our own impact on the planet, such as the rapid warming of the Paleocene-Eocene thermal maximum, our default explanation is to look for geological or biological triggers. This is a scientifically reasonable approach, but it is also shaped by the deep-rooted conviction that humans are unique in being able to alter the planet on a global scale. If we could step outside this assumption, we might view the same data with different questions in mind. Not what natural process caused this, but could an intelligent process have contributed? The problem of hubris extends beyond how we interpret the past. It shapes how we plan for the future. Believing that we are the only species ever to reach this level of advancement, we may underestimate the fragility of our position. If we think that intelligence inevitably leads to permanence, we are less likely to prepare for existential risks. Our technological capabilities give us a false sense of mastery over nature, as if our knowledge alone will shield us from collapse. But if civilizations have arisen before and been swept away, it would mean that intelligence is no guarantee of survival. It would mean that technological progress can coexist with vulnerability, and that the forces of nature, or our own self-destructive tendencies, are just as capable of ending us as they would have been for those who came before. This assumption of singularity also limits our search for life elsewhere in the universe. In the field of astrobiology, much attention is paid to finding microbial life or planets with habitable conditions, but less often do we ask whether those worlds might once have had civilizations that have since disappeared. The search for extraterrestrial intelligence focuses on detecting active signals, radio transmissions, laser pulses, or other technological outputs. But if civilizations are short-lived on cosmic timescales, the odds of detecting one in its active phase are extremely small. The universe might be full of planets where intelligence once flourished, yet now only geological and chemical hints remain. If we applied the same reasoning to Earth's own history, we might realize that other species could have risen and fallen here without leaving behind anything we would easily recognize. There is a psychological comfort in thinking we are alone in our level of advancement. It gives us the illusion that our survival is a given, that we are immune to the cycles of rise and fall that govern so much of nature. But the truth may be far less reassuring. Intelligence may be far more common than we think, but it may also be fleeting. Civilizations may emerge in different forms on different worlds or even on our own planet, only to be erased by catastrophe, environmental collapse, or their own actions. In that light, the absence of clear evidence for predecessors is not proof of our uniqueness. It is a reminder of how easily the signs of our existence could vanish too. Perhaps the greatest danger of assuming we are the first is that it robs us of humility. If we acknowledged even the possibility that others have come before, we might approach our stewardship of the planet differently. We might see our technological age not as the culmination of Earth's history, but as one chapter in a book that could be rewritten many times. We might prepare more carefully for the risks that could end our chapter prematurely. And we might look at the mysteries of the past with fresh eyes, open to the idea that some of those mysteries are not the marks of random chance, but the echoes of a story much older than our own. Human history is filled with myths, legends, and oral traditions that speak of times long past, of great powers and peoples who rose and fell before the world became what we know today. Across cultures separated by oceans and thousands of years, there are recurring themes: golden ages when life was abundant and peaceful, cataclysms that wiped away entire peoples, advanced knowledge lost to disaster, and mysterious beings who either came from the heavens or emerged from the depths of the earth or sea. While mainstream archaeology often interprets these stories as symbolic, metaphorical, or as distant memories of real but localized events, it is worth considering whether they might also contain distorted echoes of encounters with civilizations far older than we imagine. Civilizations that may not have been human at all. Many ancient stories speak of civilizations destroyed by great floods. The Sumerian epic of Gilgamesh tells of Utnapishtim, who survived a deluge sent to wipe out humanity. In Greek mythology, Deucalion and Pyrrha repopulate the earth after Zeus sends a flood to destroy a corrupt race. Indigenous traditions from the Americas, Australia, and Asia also carry strikingly similar accounts of floods that erased earlier peoples. While the flood motif could easily arise in different places as a way to explain natural disasters, it is also possible that these are cultural memories of real catastrophic events, perhaps even global in scale, that erased more than just scattered settlements. If such an event swept away an ancient civilization, survivors might have passed down the story orally, reshaping it over countless generations until it became the mythic tales we know today. Other myths speak of beings who taught humanity skills and knowledge that seemed beyond the capabilities of the societies at the time. In Mesoamerican legend, Quetzalcoatl is described as a godlike figure who brought knowledge of agriculture, architecture, and astronomy. In Sumerian tradition, the Apkallu were semi-divine sages who emerged from the sea to teach the arts of civilization. In Dogon mythology from West Africa, there are stories of amphibious beings called Namo, who came from the sky or the water, bringing wisdom and structure to the people. Mainstream interpretations view these as symbolic culture heroes, or as the personifications of important societal shifts. But if there had once been remnants of an earlier, technologically adept civilization coexisting with early humans, such encounters might have been recorded in the only way possible for pre-literate societies, as myth. Legends of lost lands and vanished cities are another recurring thread. The story of Atlantis, recorded by Plato, describes a powerful and advanced island nation that fell into the sea in a single day and night of misfortune. The Indian epics, the Mahabharata and Ramayana, describe great cities with shining towers, aerial chariots, and devastating weapons. In the Pacific, Polynesian traditions tell of sunken lands and migratory journeys from places that no longer exist. Even in Northern Europe, there are tales of Lyonesse, a land lost beneath the waves off the coast of Cornwall. While many of these stories are often linked to known events like the flooding of coastal areas after the last ice age, they could also be romanticized memories of places and peoples erased far earlier in history. Civilizations that lived in periods we now assume were devoid of technological culture. It is not only myths of destruction that intrigue, but also myths of guidance. Stories of gods, angels, or otherworldly beings giving humanity laws, moral codes, or technological secrets appear again and again in human history. Some scholars see these as projections of human ideals, but it is also possible that they represent the final contacts between declining civilizations and the younger societies that would replace them. Imagine a species on the brink of extinction, aware that it cannot survive the coming environmental or geological changes. It might choose to pass on fragments of its knowledge to the emerging intelligent species of its time. Over millennia, these encounters would become legend, with the details blurred and transformed until the original reality was unrecognizable. There are also certain ancient architectural mysteries that feed into this possibility. The precision of megalithic structures like those at Baalbek, the pyramids of Giza, or the temples of Pumapunku in Bolivia has led to endless speculation. While archaeology generally explains these feats through remarkable human skill and ingenuity, one cannot entirely dismiss the idea that some techniques may have been inherited, directly or indirectly, from interactions with a much older civilization. Even if such influences were minimal, their echoes could persist in oral traditions encoded as stories of gods or ancestral heroes who built the great works. The persistence of these myths across the globe suggests that, even if they do not describe literal truth, they may carry an undercurrent of shared human memory, a memory that could, in some cases, stretch back to encounters with beings or societies that no longer exist. Myths often serve as cultural storage devices, preserving core ideas and warnings long after the original events have been forgotten. If a prior civilization existed and its downfall was witnessed by early humans or their ancestors, the memory of it could survive in symbolic form, transformed into stories that continued to shape human identity for tens of thousands of years. Ultimately, these myths do not serve as proof of anything. They are not archaeological evidence, and they cannot be treated as historical records in the strict sense. But they may be the shadows of something that was once real, a set of shared experiences passed down in the only way possible when writing did not exist. If that is the case, then some of humanity's oldest and most cherished stories might not be pure invention. They might be the last whispers of a time when our ancestors were not alone as the planet's stewards, when other voices spoke in the dark, and when the line between history and legend was not yet drawn. For as long as humans have contemplated the mysteries of the universe, we have speculated about the possibility of extraterrestrial life. The dominant focus in science has been on the search for life beyond Earth, whether microbial fossils on Mars, biosignatures in the atmospheres of distant exoplanets, or radio transmissions from technologically advanced civilizations. But if we take the Silurian hypothesis seriously, it invites a different and perhaps more unsettling question. What if some of the civilizations that have existed on Earth were not entirely native to it? What if there is, in our deep past, an intersection between terrestrial history and beings from elsewhere? Either visitors who left traces of themselves here or ancient Earth civilizations that reached out into space and left traces elsewhere. The alien connection could take many forms. In one scenario, an extraterrestrial civilization might have visited Earth millions of years ago at a time when the planet was already home to complex life. If they stayed for an extended period, they might have established settlements, exploited resources, or even interacted with indigenous species in ways that left a mark on the planet's chemistry or biology. Over the course of millions of years, the physical evidence of their presence, structures, machines, landing sites would have been erased by the relentless forces of erosion, plate tectonics, and climate change. Only the most durable and subtle traces might remain. Unusual isotopic signatures, the presence of materials rare in nature but common in technological manufacturing, or unexplained anomalies in sediment layers. These traces, buried deep in the geological record, could be dismissed as natural oddities if we are not open to considering non-terrestrial explanations. There is also the possibility that such visitors did not simply pass through but engaged in deliberate interventions. They might have studied or experimented with life on Earth, influencing the course of evolution either intentionally or as an unintended side effect. In speculative circles, some have suggested that certain sudden leaps in evolutionary complexity, such as the Cambrian explosion, could be consistent with genetic seeding or manipulation. While mainstream science attributes these bursts of diversification to natural, environmental, and biological factors, the truth is that without direct physical evidence, we cannot rule out other possibilities. A sufficiently advanced extraterrestrial species could alter ecosystems or species in ways that, over millions of years, would appear entirely natural to a future observer. Conversely, the alien connection could also flow in the other direction. What if Earth once hosted a civilization that achieved space travel long before humans? If such a species existed tens or hundreds of millions of years ago, it could have left Earth and established outposts elsewhere in the solar system or even beyond. Traces of such activity might survive in places with little geological activity, such as the Moon, Mars, or certain asteroids. Unlike Earth, these worlds lack plate tectonics and have much slower erosion processes, meaning that artifacts left on their surfaces could endure for immense periods of time. A metallic structure buried in lunar regolith, a glassy shard of manufactured material embedded in Martian soil, or a precisely machined object hidden within an asteroid could be all that remains of a civilization that no longer exists here. Interestingly, the search for such artifacts, sometimes called the hunt for techno-signatures, is beginning to gain more scientific attention. Traditionally, SETI, the search for extraterrestrial intelligence, has focused on detecting active signals, but techno-signature research broadens the scope to include ancient relics of technological activity, even if the civilization that produced them has been gone for millions of years. If an ancient Earth civilization had reached into space, or if extraterrestrials had visited our planet, this is where we might expect to find the most enduring evidence, beyond the reach of Earth's destructive geology. Some proponents of these ideas point to certain anomalies in our own solar system that, while having plausible natural explanations, remain intriguing. Oddly shaped asteroids like Oumuamua, unusual reflectivity patterns on the Moon's surface, or enigmatic formations on Mars have all been suggested, however controversially, as potential remnants of artificial structures. Mainstream science generally attributes these to natural processes. But as with ancient anomalies on Earth, our interpretations are colored by the assumption that intelligent agents were not involved. If we shift that assumption, we might begin to design investigations that are more sensitive to the possibility of ancient artificiality. The alien connection also intersects with human mythology and cultural memory. Across the world, there are stories of beings who came from the sky, often depicted as teachers, bringers of knowledge, or destroyers. These narratives could be symbolic expressions of natural events, comets, meteor showers, or astronomical phenomena, but they could also be distorted recollections of encounters with advanced visitors, whether from another world or from an earlier spacefaring civilization of Earth. If such encounters occurred, the memory of them could survive for thousands or even millions of years in oral traditions transmuted into myth and legend. There is another layer to consider. What if some extraterrestrial civilization did not merely visit, but chose to remain in some hidden form? A species advanced enough to traverse interstellar distances might be capable of creating self-replicating machines or autonomous probes designed to study or even guide the development of life on planets like ours. These could operate invisibly to us, perhaps buried deep beneath the surface, orbiting quietly in the far reaches of the solar system, or camouflaged among natural celestial bodies. If they were placed here millions of years ago, they could still be here now, quietly recording, intervening, or simply waiting. In the broader perspective, the alien connection reminds us that the story of intelligence in the universe is unlikely to be linear or simple. Civilizations may rise and fall not only on their home worlds, but across multiple planets, moons, and even star systems. The traces they leave may be subtle and scattered, requiring not just open-mindedness, but a willingness to ask uncomfortable questions about our own place in that story. If there is evidence of such a connection in Earth's deep past, it is almost certainly faint, ambiguous, and easy to overlook, especially if we begin our investigations convinced that it cannot exist. And yet, if we allow ourselves to consider it seriously, the possibility that Earth's history is interwoven with the histories of other worlds transforms the way we think about our origins, our uniqueness, and our future. If undeniable proof of an ancient, non-human civilization on Earth were discovered tomorrow, the impact on our understanding of ourselves, our history, and our place in the universe would be nothing short of revolutionary. Such a discovery would instantly rank among the most significant moments in human history, on par with the realization that the Earth orbits the Sun or that humans share common ancestry with all other life. It would be a moment when the comfortable narratives we have built about human uniqueness would be shattered, replaced by something far stranger and more humbling. We would no longer be able to claim that intelligence, culture, and technology are uniquely human achievements. Instead, we would have to confront the reality that we are only the latest participants in a much older and more complex story. The first and most immediate effect would be a scientific upheaval. Every field, from archaeology and anthropology to geology, biology, and even astronomy, would be thrown into a state of intense reevaluation. Archaeologists would have to reconsider the methods they use to interpret ancient evidence, no longer assuming that the absence of familiar artifacts means the absence of civilization. Geologists would scour the planet for more examples of whatever markers led to the discovery, whether they were unusual isotope ratios, synthetic materials embedded in ancient rock, or inexplicable structures buried deep underground. Biologists would ask whether the beings who built this civilization were related to us in any way or represented a completely separate evolutionary experiment. The search for ancient DNA, or at least biochemical traces, would intensify, as would attempts to understand their physiology, sensory abilities, and possible cultural behaviors. The historical implications would be just as profound. Our timelines of life on Earth, long thought to be well understood in broad strokes, would have to be rewritten. We would now have to acknowledge that there were multiple technological ages in Earth's past, separated not by centuries or millennia, but by millions of years. The rise of Homo sapiens would be reframed not as the beginning of advanced life on Earth, but as one of many peaks in a long series of rises and falls. In this light, our own civilization would seem less like the inevitable culmination of evolution, and more like a temporary phenomenon, one that could vanish as completely as the one we had just discovered. The cultural and philosophical consequences would be equally staggering. Humanity's sense of exceptionalism, already challenged by centuries of scientific progress, would face perhaps its final blow. For millennia, religions, philosophies, and ideologies have been built on the idea that humans hold a special place in creation, whether by divine design or by virtue of being the only species to achieve higher intelligence. Proof of a pre-human civilization would force religious leaders to reinterpret sacred texts, either incorporating these ancient beings into their cosmologies or finding ways to reconcile their existence with long-held beliefs. Some might see them as part of a divine plan, others as fallen creatures, or even as cautionary examples of what happens when a civilization overreaches. Philosophers would grapple with the moral and existential implications. If intelligence is not unique to us, then perhaps consciousness itself is a recurring feature of life, arising and disappearing across eons. Politically, the discovery would be a double-edged sword. On one hand, it might unite humanity in a shared sense of wonder and curiosity, as the petty divisions of our current moment would seem trivial compared to the deep history we had just uncovered. On the other hand, it could also fuel new tensions. Nations would compete to control access to the discovery site, claiming ownership of the evidence and the prestige that comes with it. Questions of who gets to study the remains, who controls the narrative, and who benefits from any technological insights could spark geopolitical rivalries. If remnants of their technology were found and proved adaptable to our needs, the stakes would grow even higher, as the potential for scientific and military advantage could drive secrecy and conflict. The public reaction would be unpredictable. For some, the discovery would be exhilarating, a validation of long-suspected possibilities, a confirmation that the universe's history is stranger than we imagined. For others, it would be deeply unsettling, even frightening. Conspiracy theories would flourish, claiming the discovery was either fabricated or part of a hidden truth long suppressed by governments. Popular culture would be transformed overnight, with films, books, and art inspired by the idea of multiple intelligent species sharing the same planet across deep time. Museums would rush to create exhibits, while journalists and documentary makers would scramble to tell the story to a hungry global audience. One of the most lasting effects might be on how we see our future. If another species reached technological sophistication long before us and then disappeared, The obvious question would be, why? Did they destroy themselves through war or environmental collapse? Were they wiped out by a natural disaster beyond their control? Did they leave Earth intentionally, venturing into space to start anew elsewhere? Or did they fade away in some way we cannot yet imagine? These questions would not be mere historical curiosities. They would be urgent warnings, forcing us to look at our own trajectory in a new light. If they could vanish, so could we, and perhaps more quickly than we think. The discovery could also change our approach to searching for extraterrestrial life. If intelligent civilizations can rise and fall on the same planet across vast spans of time, then the likelihood of finding similar patterns elsewhere in the universe increases dramatically. Instead of looking only for active civilizations broadcasting signals, scientists might focus more on the archaeology of the cosmos, searching for the ruins of past civilizations on other planets and moons. The understanding that intelligence is not a one-time event, but a recurring possibility could reshape our expectations of what the universe might hold. In the end, proof of a pre-human civilization would be a humbling reminder of our place in the grand sweep of time. It would show that intelligence, for all its wonders, is fragile, that civilizations, no matter how advanced, are temporary guests in the unfolding story of life on Earth. It would challenge us to see our own age not as the final word, but as a fleeting chapter in a book that has been written and erased more than once. And perhaps, if we are wise, it would inspire us to ensure that our chapter lasts as long as possible before the page inevitably turns. If we step back and imagine the Earth millions of years from now, long after our own civilization has either transformed beyond recognition or disappeared entirely, the question becomes, what will remain of us? This is not just a question for archaeologists or geologists. It is a profound meditation on legacy, memory, and the impermanence of human achievement. The Silurian Hypothesis forces us to confront the possibility that any trace we leave behind could be as faint and elusive as the hypothetical traces of civilizations that may have preceded us. To future beings, whether human descendants, another evolved species, or visitors from beyond Earth, our entire age of skyscrapers, satellites, and sprawling cities might be reduced to a thin, peculiar layer in the geological record. One of the most likely remnants of our civilization would be a chemical signature. Our burning of fossil fuels has already altered the atmosphere in ways that will be detectable for millions of years, changing carbon isotope ratios and leaving behind layers of soot in ice cores and sediments. The synthetic materials we produce, plastics, certain alloys, long-lived industrial chemicals, could also persist, though perhaps not in recognizable form. Over geologic timescales, plastics might degrade into microscopic fragments, but those fragments could still be identifiable as polymer residues embedded in sedimentary layers. To a future geologist, these residues could serve as clear indicators of an industrial phase, much as iridium-rich clay marks the asteroid impact that ended the age of dinosaurs. Our structures, however monumental they seem to us now, are far less likely to endure. Even the greatest stone monuments are vulnerable to erosion, earthquakes, and the slow grinding of glaciers. Our tallest buildings, made of steel and concrete, would crumble within a few thousand years without maintenance, their metal skeletons rusting away and their glass shattered to dust. Coastal cities would vanish beneath shifting seas or be buried under silt. In time, plate tectonics would recycle most of our built environment into the mantle, erasing it entirely. The exceptions might be structures buried deep underground, such as tunnels, vaults, and subterranean storage facilities. Some of these could survive long enough to intrigue a future civilization, though their original purpose might be completely lost to interpretation. One of the more enduring legacies might come from what we have sent into space. Our satellites in low Earth orbit will eventually fall back and burn up in the atmosphere, but those in higher orbits could remain for tens of thousands of years before being perturbed into decay. The small handful of spacecraft we have sent beyond Earth's orbit, such as the Voyagers, Pioneers, and New Horizons, could persist for millions of years, drifting silently between the stars. If a future intelligence were to find one, it might serve as a message in a bottle from a vanished species, though whether they could decode its meaning would depend entirely on their curiosity and ability to interpret an artifact from an alien mind. The biological legacy of our time could be more enduring than our architecture or technology. We have domesticated animals and plants, altered the genetic makeup of countless species, and introduced invasive organisms into ecosystems around the globe. Some of these changes could persist long after we are gone, shaping the evolutionary path of life in subtle but detectable ways. Fossil records might reveal sudden bursts of extinction followed by unusual patterns of biodiversity, perhaps analogous to those seen in previous mass extinctions. A future scientist piecing together these clues might infer that a global force, whether a natural catastrophe or an intelligent agent, had dramatically reshaped life on Earth. There is also the possibility that our most lasting imprint will not be material at all, but informational. If we succeed in storing knowledge in ways that can withstand vast stretches of time, etched into stable crystal matrices encoded in DNA or inscribed in protected archives on the Moon or Mars, then a fragment of our culture, language, and history might survive to be discovered. However, even if such information endures physically, its meaning could be lost without the cultural context to interpret it. A future intelligence might find our records as baffling as we find the undeciphered scripts of ancient human cultures. The knowledge that so much of what we build and create could vanish forces us to think about legacy in a different way. If civilizations have risen and fallen before us, their traces reduced to a few scattered anomalies in the rocks, then we too are destined to be a layer in the Earth's deep time. A momentary flash in a story that stretches billions of years in both directions. This realization can be sobering, but it can also be freeing. It reminds us that the permanence we imagine for our monuments and achievements is an illusion, and that our true impact might lie in how we shape the living world and the ideas we pass forward. Perhaps the most humbling thought is that a future civilization might find evidence of us and draw conclusions as speculative as our own about any who came before. They might debate whether the strange chemical and material traces in the rocks were really signs of an intelligent species or merely the product of some unusual natural process. They might argue over whether we destroyed ourselves, fell victim to natural catastrophe, or transcended the planet entirely. And just as we today wrestle with the uncertainty of the deep past, they too would have to accept that some questions about us may never be answered with certainty. The Silurian Hypothesis ultimately forces us to confront the most unsettling possibility of all: that the story of Earth is not a simple tale of steady biological evolution culminating in humanity, but rather a cyclical pattern of rise and collapse, with multiple waves of intelligence emerging, flourishing, and vanishing over the planet's vast history. If that is the case, then our own civilization is not the pinnacle of creation. It is merely the latest chapter in a book that has been written and erased countless times. This perspective demands that we rethink not only how we view the past, but also how we imagine the future, because the forces that might have ended previous civilizations, whether natural or self-inflicted, are still at play today. One of the most profound implications of this idea is that intelligence, rather than being an extraordinary and rare anomaly, could be a recurring evolutionary strategy. Life on Earth has proven astonishingly resilient, rebounding from asteroid impacts, massive volcanic eruptions, ice ages, and sudden climate shifts. If intelligence confers adaptive advantages, problem-solving, tool use, social organization, then it may be that nature tends to produce it given enough time and environmental complexity. But intelligence is also a double-edged sword. It allows for unparalleled control over the environment, yet that very control can lead to overexploitation, ecological collapse, and self-destruction. The fossil record shows that complex ecosystems can unravel quickly when disrupted, and a technological species is uniquely capable of accelerating such disruption. If there have been other civilizations before us, they may have faced challenges that sound eerily familiar. Resource depletion, climate instability, and habitat destruction are not uniquely human problems. They are the predictable consequences of any species that alters its environment faster than it can adapt to the changes. The difference is that we have the capacity to understand these processes in real time, to model them, and to act deliberately to avoid catastrophe. Yet history, even the fragmentary hypothetical history the Silurian Hypothesis invites us to imagine, suggests that knowledge does not always translate into wisdom. A past civilization might have seen the warning signs of collapse, debated solutions, and still failed to change course before it was too late. The cyclical view of history also raises the possibility that each wave of intelligence inherits in some indirect way the conditions left by its predecessors. If an earlier civilization altered the atmosphere, changed ocean chemistry, or drove mass extinctions, those changes could have shaped the path of evolution for millions of years afterward. Our own existence might, in part, be the product of such distant legacies. And in turn, the environmental and chemical signatures we are creating now, our carbon emissions, synthetic compounds, and redistributed species, could influence the emergence of the next intelligent species long after we are gone. In this sense, every civilization is both a culmination of the past and a seed for the future, whether or not it survives to see what comes next. There is also the haunting question of whether civilizations can escape the cycle entirely. Could an intelligent species achieve technological mastery without destroying its own biosphere? Could it survive long enough to establish a permanent presence beyond its home planet, ensuring that it would not be extinguished by a single planetary catastrophe? If so, then perhaps the reason we find no clear evidence of past civilizations is that the successful ones have left. They may have moved into space, adapted to new worlds, or transformed themselves in ways that make them unrecognizable to us. To a species that has achieved such longevity, the early, fragile phase of civilization on a planetary surface might be seen as a brief adolescence, one that many do not survive. For humanity, this perspective is both sobering and motivating. It suggests that our survival depends not just on technological progress, but on cultural and ethical maturity, on learning to see ourselves as stewards of a planet rather than its exploiters. The geological record is a stern reminder that Earth's environment is not infinitely forgiving. Ice cores, sediment layers, and fossil assemblages all tell stories of abrupt changes and irreversible losses. If we fail to navigate the challenges we face, we could leave behind only faint traces for some future intelligence to puzzle over, just as we now search for signs of those who might have come before. The Silurian Hypothesis at its core is not about proving that ancient civilizations existed. It is about recognizing the fragility of our own. It urges us to see the present moment not as a permanent state, but as a fleeting window of opportunity in the long sweep of planetary history. If we are indeed one of many civilizations to rise on Earth, then our most urgent task is to ensure that we are not merely another layer in the rocks, another mystery for the distant future to speculate about. Instead, we have the chance to break the cycle, to carry the story of Earth's intelligence beyond the boundaries of this planet, and to ensure that our chapter in the Book of Life is not only preserved but built upon by whatever comes next. And so, when we step back and look at the possibility that Earth may have been home to not one but many civilizations across its deep history, we are left with a strange mixture of awe and humility. Whether the Silurian hypothesis turns out to be true or remains only a thought experiment, it forces us to see ourselves against the backdrop of geological time, a stage so vast that even the greatest empires and most dazzling achievements become fleeting moments. It challenges us to think not only about how we came to be, but about what we will leave behind and how we might shape the future in ways that endure. Perhaps there were others before us. Perhaps there will be others after us. But right now, in this moment, we are the caretakers of the only known civilization in the universe. The question is not just whether we are alone in time, but whether we will make our time matter.